Okay, so in this lesson, we're going to move forward. We've already taken care of radians and degrees. We've looked at the points and angles on the unit circle. And really the next and the biggest step is probably to look at sine, cosine, and tangent values on the unit circle. So that's where we are. We also already covered this last topic, negative and coterminal angles. So these last two, what we'll do is we'll take, in this lesson, we'll take a look at the sine, cosine, and tangent values, and in the next lesson, reciprocal trig functions, and then a review. So in this section, this lesson, sine, cosine, and tangent is what we're looking for on the unit circle. And there's lots of ways to show this, but if we take a look at this triangle that we had using the pi over 6 unit circle, we can remember that that has a hypotenuse of 1, and using just the basic trig identities of SOHCAHTOA is what we usually call them. If we want to find, for instance, the sine of this angle that we've been using, sine of theta there, we can use opposite over hypotenuse. Well, the opposite happens to be the y value of this triangle. Hypotenuse is just 1, so opposite over hypotenuse is y over 1. Sine is simply y over 1, or y divided by 1 is just y. If we move a little further, cosine is adjacent over hypotenuse. So for this angle, the adjacent side comes from the x value of that point. So for theta, the adjacent side here is the x value, x divided by the hypotenuse, which is 1 still. So cosine of theta equals x over 1, which is just x. Works very nicely. So if I know, and we already do know, the x and y values, we can automatically know, or we already know, the sine and cosine values. We'll illustrate this in a second with an example. But one last thing, one last item, is to take a look at the tangent values of these angles. So right there, tangent is the opposite over adjacent. Well, the opposite side is the y, the adjacent side is the x. So tangent of theta equals opposite, which is y, divided by x. Y over x. This formula for tangent should be reminiscent of the slope formula. Slope formula we know is y2 minus y1 over x2 minus x1. That's one good way to remember that it's y over x and not x over y. Just if you can remember the slope formula, that gives you the indication there of that tangent value. You can also, of course, go back to SOHCAHTOA and remember it's opposite over adjacent and keep this triangle in mind. That helps out a lot too. So these three identities, these three formulas for sine, cosine, tangent, give us our values from the unit circle. So let's take a look. I'm going to get rid of this triangle, clean up some of this stuff a little bit. Okay, so I've cleaned up a little bit, and we've got sine, cosine, and tangent. Let's just look at pi over 6, since that's the triangle we've been using. This works for all angles, but we'll just go ahead and take a look quickly at pi over 6. The sine value of pi over 6, I know this point, this point right here is square root 3 over 2 and 1/2, which we've learned in previous lessons. So the sine value of pi over 6, if I want to know sine of pi over 6, or if I want to know sine of 30 degrees, since that's a 30-degree angle right there, if I want to know the sine of that, that's just the y value, which is 1/2. If I want to know the cosine value of pi over 6, it's the x value, as we just demonstrated, so that's square root 3 over 2. And if I want to know the tangent value, that will require a little bit more work. Not too bad. It's y divided by x. So just real quickly, 1/2 divided by square root 3 over 2. If we remember our fifth grade math, I guess. We multiply the reciprocal of the second value there. So that's going to be equivalent to 1/2 times 2 over the square root of 3. I'm going to run out of room here, so I'm going to clean this up in just a minute. And so with a little bit of magic, I've cleaned that up a little bit to have enough room to finish. We just multiplied by the reciprocal here, so that's going to be the 2's cancel out. We have 1 over the square root of 3. And we have to rationalize, keeping in mind that we don't usually leave radicals in the denominator. I have seen some changes recently in some programs, but generally speaking, we don't leave those radicals down there. So multiply by square root of 3 over 3. On the top, in the numerator, we get the square root of 3. In the denominator, square root of 3 times square root of 3 is square root of 9, which is just 3. So my tangent of pi over 6 is the square root of 3 over 3 when simplified. So we've got sine, cosine, tangent values. We will review these again at the end in the review, but those work for all the different angles we've seen. It's a very elegant, very nice, efficient way to find those values.